Good morning. We are continuing the Pythagorean theorem word problem lesson. This is probably going to be my last lesson with Pythagorean word problems. After I do these, I'm going to do 4 of maybe what are the trickier problems. But at this point, you either understand it or you don't, and Pythagorean theorem isn't all that difficult once you get the gist. I am assuming you watched my other video of word problems where we did Miss Cruz was walking was one of them, and we talked about the ladder, that was one of them. So I'm assuming you did those 2, and now I'm up to number 3. I'm going to do 4 word problems in all. Can I please encourage you, when I get to a new word problem, like the one you're looking at, maybe you could pause it, get a piece of paper, and try it yourself before I teach it to you. That would actually be great for all 4 of these. Watch me present the new one, pause it, solve it, and even you can fast forward till I get to the right answer to see if you're right. But I picked, out of the 4 questions, I would say 3 of them are tricky, in my opinion. If I were giving you a test, you know that these would be the ones that I would like. I hope I see you to give you a test. Okay, so here's number 3. Please pause it and solve it if you'd like. I'm going to continue to solve it. So again, if this were a test, I might not give you this picture. Here's my perfectly square window. It's 3 feet by 3 feet. Okay, here's the tricky part. I want to know if a piece of plywood, okay, plywood is like, it's thin, it's not always that heavy. It's a flattish piece of wood, and it's 4 by 6. They didn't really tell you how thick it was, doesn't matter. So I want you to picture, right, a really long flat board, and I want to shove it through this window. So I could shove it through horizontally, and it wouldn't fit if it's 4 by 6. This is only 3. So if I shove the board through this window, it's not going to fit horizontally. It's not going to fit vertically. I'm wondering, get it, if it would fit diagonally, which would be the hypotenuse. So I'm wondering what this hypotenuse is to see if I could shove this through. It doesn't matter how long it is. It could be really, really, really long, and I just keep on pushing it through. What matters is how wide it is. This is the number that matters. So I am going to find that hypotenuse, okay, 3 squared and 3 squared is c squared. Okay, I have my calculator here always, right? Okay, so we have 9 plus 9 is c squared, 18. Please remember, radicaling c gets rid of the squared. So if I radical the c, I radical the 18. I did it on my calculator and I rounded, I get 4.2 feet. So picture this, okay, not done. This hypotenuse is 4.2-ish, a little more, right? We rounded feet. If this board is 4 feet, doesn't matter how long it is, can I fit this diagonally through the window? And the answer is yes, I can. I have a little few inches, right? A little bit, I have to be careful, a little bit of room. This is smaller than the hypotenuse, so it can fit. That's the tricky part that kids have a hard time with, applying this word problem to the Pythagorean theorem. So I'm going to switch word problems. Okay, here's that famous ladder problem. Okay. I don't consider this one too hard. No tricks here. All right, so here's my 37-foot ladder. I've told you the ladder is always the hypotenuse. I don't care if you draw the triangle this way or this way, doesn't matter, but the ladder is always the hypotenuse. You could always leave units to the end, okay? You don't even have to draw the ladder. We are also assuming, right, this is always the house, this is always the ground, and so that's always a right angle. The base of the ladder, here's my base of the ladder, is 12 feet from the wall. Here's the wall because this is my house. So this becomes one of the legs. So I'm going to do a squared plus b squared is c squared, right? I'm going to make, that's my base, that's my leg rather, right? I'm looking for this, and I have the hypotenuse. So I know 12 squared is 144. I don't know what 37 squared is. Okay, don't forget we're solving for b. So b squared, 1369 minus 144 is 1225. I have no clue what that is. Then I get 35, no rounding. So from the base of the house to where the ladder reaches, this is going to be 35 feet. I'm hoping that one was kind of easy. I have 2 more to go. Okay, this one is definitely tricky. If you want to read it and pause it and try solving it, there's a little trick in here that kids always fall for. Okay, so pause it if you want. We have Ken and Kathy. Okay, so they're horseback riding. And Ken is riding north, right, north at 3 kilometers per hour, right? They start, I guess they didn't say that they started at the same place. And Kathy rode west, and Kathy's riding a little bit faster at 3.5 kilometers per hour. Okay, here's the trick. How far apart were they at 2 p.m.? Well, they started riding at noon. Get it? So this number after 2 hours becomes a 6 kilometers. And this number after 2 hours becomes a 7 kilometers. Now it should be easy. They want to know how far apart they are. Okay, so you could see kids would get tricked, read this too quickly, say it's easy, and use 3 and 3.5 instead of using 6 and 7 to see how far apart they are. So now it's easy. I gave you the trick. So we have 36 and 49 is 85. And then if I radical 85, I get, let's round to the nearest whole kilometer. I think I'm getting 9. They are 9 kilometers apart. Okay, so the trick was that it went from noon to 2 p.m., so you had to double those. Last problem. I'd say this is a little tricky because TV antennas don't really look like this anymore. So this might be one where you need to see me draw that picture. Probably a little different for you. Okay, ready? Here is my TV antenna. There it is, okay? It's braced on 2 sides with 20-foot lengths of wire. I hope you remember, I don't know, isosceles triangle, do you remember that? Right, 2 sides are the same. So these 2 sides are the same. Okay, and the base, here's my base, right? There's my right angle, so this is my height. This is my base. My base is 24 feet. I'm asking how tall the antenna is. I want to know how tall X is. Here's the trick. Here's the trick. Here's my right angle, right? There's my right angle. So this is 12 and this is 12. I don't know that you guys could have gotten that picture by yourself. I don't know if I'd put that on a test. This is a tricky picture to get by yourself. And once you have this picture, right, it's pretty easy. So I have 12 squared. I'm missing this leg is b squared. I called it x, doesn't matter. My hypotenuse is 20. So that's 144, and b squared is 400. I probably can do that in my head, but it's actually pretty early here. So, nope, I didn't mean, yeah, minus 144. I didn't show that, sorry. So b squared is 256. And if I am radicaling 256, I am getting that the antenna is 16 feet tall. Okay, so let's just see, right? Does this make sense? If this is 12 and this is 20, 16 as my final answer makes sense here. Okay, I am probably not going to give you any more Pythagorean theorem word problems. You got the gist of it. You know, I gave you a packet already with answer keys. So I hope that you're showing your work and checking as you go. Have a great day. I miss you guys. Bye. No dogs to show you today. Maybe later. Bye.